Okay, it's time for something a little different. We're going to learn about the Cartesian plane. This will become more obvious why we're doing that in the next couple videos. You've probably learned this before. I think you've probably learned this before. Does this look familiar, what we're looking at right here? Does that look familiar? If so, you've probably looked at the Cartesian plane before. Now, you might not have called it Cartesian plane because it's also called the coordinate plane. And this thing was first published, created. Other people actually had thought of it as well, but by a French guy, very brilliant man named René Descartes in 1637. You see how the name comes, this Cartesian plane. I see cart right here and cart right there. So it's kind of like the Descartesian plane, but I guess it became Cartesian plane or something like that. Anyway, the story is he was lying in bed one day and he was looking up at his ceiling. He saw a spider up there and he was trying to figure out how could I describe to someone where that spider was located. And he had this idea of kind of breaking the ceiling up into this grid-like thing here. And you could name where the spider is by kind of identifying one of the grid points. So the Cartesian plane helps identify a point on a grid. So let's talk about this Cartesian plane that you're looking at right here. So basically you've got these two lines here. You know what those are called? Those are called axes. If it's plural, you write it like this: axes. No, not that. If there's only one of them, it's called an axis. So this one here, as you can see, there's an X there. That's because this line here is called the X-axis, and this one here is called the Y-axis. Again, I bet you know most of this, don't you? Now, when you cross those two lines, the X-axis and the Y-axis, you kind of end up with four different areas, don't you? You end up with this area here, you end up with this area here, you end up with this area here, and you end up with this area here. Four of them. Oh, it's so pretty. Do you know what you call those four areas? Each one of them has a name. They're all called quadrants. Quadrants. And now we're going to name the quadrants specifically. They're not very unique names. Their names are 1, 2, 3, 4. Now, I know what you're thinking. You're thinking right here, this is quadrant 1 right here, right? No. This is quadrant 1 over here. Okay, the other weird thing about quadrants, when you write the number, you use a Roman numeral. Okay, so that's quadrant 1. This is quadrant 2 over here. I'll give my best explanation for why they start 1 over there in a second. Here's quadrant 3, and this is quadrant 4. Okay, so what else? Okay, this point right here, right in the middle, you know what that point's called? That point is called the origin. What's origin mean? The origin of something is the beginning of something. And this is kind of the beginning of the coordinate plane, because whenever you're going to graph a point, you always start here and then start counting one way or the other way. So that's the reason it's called origin. Now, every single point on here, you know, there's a point, there's a point, there's a point. You can even put a point in the middle here like that. All those are identified with an ordered pair. So let's take a look at those two words. It's an ordered pair. The pair means that there's going to be two numbers that are going to symbolize or represent every single one of the points on here. It's going to be 2. You can't say, oh, this point right there, that point there is 7. No, you need to represent it with two numbers because there's two dimensions here. So that's the pair part of it. Ordered means there's a definite order to the pair, right? If you write 3, 5, that's an ordered pair, but it's certainly a lot different than 5, 3. So we need to make sure we put it in the right order. All right, let's go back and talk about the origin for a second here. This ordered pair for the origin is 0, 0. Okay, that right there, if you wanted to represent that point, it's 0, 0. Okay, why do we call this quadrant 1? I don't know this for a fact, but I think it makes sense that the reason we call this quadrant 1 is because when you first start doing these sort of things, your teacher probably didn't draw all four quadrants. They probably only drew one of them, right? And then you put points in the single quadrant, and you might have said this point was 2, 3 or 3, 4 or whatever. The thing about in this quadrant, all the numbers in the ordered pair, I guess both the numbers in the ordered pair, they're both positive. it's a positive number and then another positive number. That's not the case for these other ones. In quadrant 2, it's a negative number and then a positive number. The first number is negative, the second one's positive. In quadrant 3, they're both negative, and quadrant 4, the first one's positive, the second one's negative. So I think that's probably why this is quadrant 1, because it's the most basic quadrant. It's where you started from when you first learned this. Okay, let us graph some points. Okay, we're going to graph 8 points here. I'm not going to do them in order though that I've written them. I kind of put them in a weird order. I'm going to start with this one. 3, 4. So here's the thing to remember. You're going to move along the x-axis before you move along the y-axis. X comes before y. Or the little expression someone once taught me was, when you're a baby, you got to learn how to crawl before you learn how to jump. I don't know. Okay, so here's what you do. You start at the 0, 0, right? The origin. Origin means start. Start there. You're going to move in one of these two directions first, and then one of these two directions next. Horizontal, then vertical. So on the x-axis, coming out this way is all the positive numbers. Look at 1, 2, 3, 4, 5, 6, positive. Coming out this way is all the negative numbers. Negative 1, negative 2, negative 3, negative 4. Going in the y direction, it's positive going up this way, and it's negative going down that way. So if we were going to graph this point, we're going to go 3. So we start here and we go 3. 1, 2, 3. Do not put a point there. You're not finished because the second number is 4, positive 4. So we went over 3 and then we're going up because it's positive 4. 1, 2, 3, 4. There's your first point. So put a dot and I'll put an E there to show that one. Okay, next one. Let's do this one. F. Negative 5, 6. So we start at the origin, negative 5. So remember, we're going one of these two directions first, and it's negative. So we go 1, 2, 3, 4, 5 right there. And now the second number is positive, so we're going to go up, right? And it's 6. 1, 2, 3, 4, 5, 6. There you go. There's our F. Okay, next, let's do a 6 and then negative 4. So 6 is positive, and we're going one of these two ways. Always crawl before you leap. So we have to go 6 out this way. 1, 2, 3, 4, 5, 6. And then the second number is negative. So we're actually going to go down. Negative 4. 1, 2, 3, 4. There you go. That's A. All right, let's go with C next. Negative 5, negative 2. So we start at the origin. It's negative, so we're going this way. 1, 2, 3, 4, 5. And it's negative again. 1, 2, there is point C. Okay, now we get to the harder ones. Let's start with this one, 0, 7. So here's what a lot of people do. They go out here and they put their dot right there. That is incorrect because look, the 0 means you're going to go not at all in this direction. You're just going to stay at the origin. Then you're going up 7. 1, 2, 3, 4, 5, 6, 7. This is B right here. How about D, negative 3, 0? Well, this time the first number is negative 3, so you're going to move in the negative direction. 1, 2, 3. And how much do you go up or down? 0. You don't go up or down at all. So you just stay there. When you get to negative 3, you just stay there. So there is point D. Now, so far all the points we've done, I call them pretty points. It's not really what they're called, but I call them pretty points because they're right in the connection of two lines, right? They're the intersection of two lines. They're really exactly, I can put the point exactly where they go. But you can also have points in the middle of nowhere like this. So I just did a couple of these. These are not pretty points. Remember, that's just my term, but these are not pretty points. So we're going to do G and then H. So G says 3. So we're going to start at the origin. We're going to go over 3, 1, 2, 3, and then we're going to go down, since it's negative, down 2.5. So over 3, then down 1, 2, and a half takes us right here. So it's hard to get exact here, but we can do the best we can. That looks about 3 and negative 2.5. Okay, and the last one is going to be a very strange one. It is negative 3.5. So negative 3.5 would be 1, 2, 3, and a bit, so here. And then we have to go up 1.8. Well, there's 1, and we want to be 1.8, so it's closer to 2, isn't it? So it's going to be somewhere there. Now, am I guaranteeing that's exactly where it is? No, but it's pretty darn close, right? If I make my dot a little bit bigger, I'm for sure it must be there. So there's my H right there. If you understand all that, you understand how to graph points. The other way they might ask it is they might give you the point, and you have to say what the point is. Give the ordered pair for it. So I'll just quickly do this as well. A. Remember, we start here. We're going to go over. We're going to go one of these ways first. So we got to go over 1, 2, 3. So there's my first number, and then I'm going up 1, 2, 3, 4, 5. Great. B. I start at the origin. I'm going over 2 to the left, so that's negative 2, and then I'm going up 1, 2, 3. So that's positive 3. C, I'm going over 3 again, or over 3 to the left, 1, 2, 3, so it's negative 3. And then I'm going down, so it's negative again, 1, 2, 3 again, negative 3, negative 3. D, be careful. Don't put negative 5 first. If you wanted to graph this point, how far are you going left or right? You're not going left or right, so it's 0. And then you're going down, 1, 2, 3, 4, 5, so it's negative 5. E, you're going to start by going over 3 to the right, and then you're not going up or down, so it's 0. And F, you're going all the way over to 6. So 6 is the first number. You're not going up 1. I don't know, is that 0.5, 0.4? I don't know. Can't really tell, right? I'd either say 0.4 or 0.5 or something. What the heck, I'll put 0.5. And there you go. That is graphing on a Cartesian plane. So we'll be using this in the classes ahead. So if you have any troubles, make sure you ask. You don't want to be struggling with this as we move forward. Take care, everyone.